Alrighty, I guess I am back to doing Leetcode. All right, took a fairly long break, but let's see if I can't restart it here. Okay, so easy. I previously solved this one. Find the largest almost missing integer. You're given integer a, nums, and integer k. An integer x is almost missing from nums if x appears in exactly one subarray of size k within nums. Appears in exactly one subarray size k. Return the largest almost missing integer from nums. If no such integer exists, they return -1. A subarray is a contiguous sequence of elements. So 39217, k equals 3, output 7. 1 appears in exactly 2 subarrays of size 3. 921 and 217. 2 appears in 3 subarrays. Okay, 392, 921, 217, sure. 3 appears in exactly 1 subarray size 3. 7 appears in 1. 9 appears in 2. So I think here any element that is not the first or the last element would have to appear in more than one subarray, right? Because it's just how it would work. It's unless k is 1. Assuming the elements are all unique. So I think my initial thing is like it's either the first or last unless it's a duplicate and unless it's k equals 1. I think I'm going to deal with k equals 1 first because that's a very special case, in which case I can't really assume that the inner non-first and last elements are part of 2 subarrays. So if k equals 1, then I'm looking for the largest one that's not duplicated. The largest one that's not duplicated. I guess I could track. Do I need to use a counter here? The largest one that's not duplicated. I wonder if I should. Can this be done? Can this be done with a heap? Heap of size k. But then I would need to know whether or not it's duplicated. I think I need a counter. I think I need a counter. Yeah, I think a counter plus one iteration to go through the counts to find the maximum count that doesn't have that has a frequency of 1. If it is k equals 1. So I'll deal with the special case. This were non-n elements um, are in individual subarrays. So if k equals 1, then I want to do. So I need to actually run a counter. Yeah, I think I need to do a counter. Counter to get the frequency of each value. And then I need to find the counts where the frequency is 1. For every think the counts is is it paired? I don't think it's paired, right? It's not like a key value, it's a pair. It's not like a tuple I can iterate over. Maybe I can. I wonder if I can do that. Yeah, it's not iterable like that. It's yeah. What is the iteration over key values in a mapping? All right, for every, let's say key, or let's say every value in counts. If the count to that value, which is the frequency of it, is equal to 1, and that value is greater than max value updates. And then I return the value there. Okay, this should work for k equals 1. It doesn't work. Wonder why this didn't update to 9. Every value, max value. Oh my god, I'm an idiot. Return the max value. All right, and then otherwise can assume that all non-n elements are ineligible. They are part of greater than or equal to 2 subarrays. So I just need to identify if first or last is bigger and also is not part of the array. So let's say I get the frequency of the first and the last one. First frequency is, or let's say, yeah, first frequency is equal to the last frequency, which is equal to 1 currently. For every value in nums, if the value matches nums at 0, first frequency increments, value equals nums, the last value. I wonder. This iterates over everything, doesn't it? What if I just did something like first frequency is first frequency, last frequency. Actually, let's say first repeat, last repeat, false. Let's iterate over everything from 1 on. If it matches the first value, Then first repeat equals true. Break for every value in nums up to last. If I wonder if there's a better way of doing this. If the value equals nums, the ending value, last repeat equals true. And then there's just more logic here. If not first repeat. So I can't have any repeats. And also I can't, it needs to be the bigger of the two. If the first in repeat and the last in repeat, then return the maximum of the two values at the front and the back. So here and here, this means one of them repeats. So I have to return the one that doesn't repeat. So if it doesn't repeat the first, then just return the first. Else, if it doesn't repeat the last, no, I guess. Yeah, else if not, last repeat. And then the final case is just return -1. This is pretty, I wonder if there's a better logic for this, although maybe it doesn't make a difference. Oh boy. This did not return -1. No, it did return 0. K equals 2. Oh, K equals 2. I see. It's because this thing is the whole subarray. Wow, this is, I'd say this is closer to medium than easy. There's no integer that appears in only one subarray. I see. There's no integer that appears in only one subarray. So if it covers all of the array, then I would look for the biggest one that appears once. No. If it covers all the subarray, the subarray covers all the array. No, what is this? It's not the same as the example. Okay. So the biggest number that appears, so the number can duplicate. The biggest number that appears in only one subarray. Okay, so I think this is just a special case. k equals length, return biggest value in array. So if k equals the length of nums, then return the maximum. Whoops. I'll be honest and say I didn't catch that logic very well. Okay, interesting. I don't think this is great. Okay, but whatever. Okay. Summary. I think the above has some logic that could be simplified, maybe. In general, handled the three special cases or two special cases. K equals 1 and k equals length, or k equals length. Simply return the largest value of in the array, because that's what it means anyways. And then for k equals 1, return the largest value that appears at most once, or at exactly once. So use the counter to quickly get the counts or the frequency of values and iterate once over them using a for loop to find the max value whose frequency is 1. That's this part, right? And then for general case, for other general case, and ignore all elements in the middle, not at the end, not at the end, since they, by definition, will appear in at least two subarrays. At that point, just need to determine if either of the front or back element are best, is best, or is better. If both appear once, then return maximum, return larger of the two. Otherwise, return either that appears once. Otherwise, return nothing. So if they both appear once, then the largest missing is the bigger of the two. If it doesn't both appear once, then one of them repeats and one of them doesn't repeat, possibly. So we return the non-repeating one. And then otherwise, but they both repeat, so therefore return -1. Complexity is definitely O of n, since all methods cases rely on single passes or multiple single passes of the array. No sorting involved. Base complexity, this can be O of 1 since keeping track of, well, I don't know actually. Counts could possibly be O of n if every value is unique. Hmm. I don't know. O of n for usage of counts. Yeah.